Okay, today we'll be analyzing quadratics and writing the equations for quadratics. We're going to try to put two lessons in one. That way we can get ready for the quiz tomorrow. So there's some things I want to explain to you before we kind of go through these notes. There's some things that y'all haven't learned before and some things y'all need refreshers on. So if you look at your notes, we're going to find the vertex. Okay. So I'll go through and explain what each of these mean. You probably know what some of them are, but I'll just go through and explain. Your vertex is going to be that point where it starts to change direction. So it could be the highest point if it's upside down for your parabola. So it could be the highest point, and we call that the max value, the highest. It could be the lowest value if your parabola is right side up. But that point is going to be your vertex. So it could be your maximum or your minimum. Axis of symmetry, we went over yesterday. A little more. Axis of symmetry is always going to be x equals something. You have to have x equals, okay, or else it will be wrong, because we're talking about a vertical line, not just a point. We're talking about the entire line. So make sure you have x equals. And if we want to write some of these down, there's blank space on the back of your notes that you can write this down on, so you have it. Okay, so that's your axis of symmetry. Another thing I want to point out is, and we talked about this yesterday, it will always be the x value of your vertex. So if you know what the vertex is, you know what the axis of symmetry is. It's just the x value. Okay, your max or min value. Oops. Your max or min, we talked about it up here. It could be a maximum if your parabola is flipped upside down. It could be a minimum if it's right side up. But it will always be the y value of your vertex. So whenever you do your max or your min, I want you to circle which one it is and then tell me y equals blank. And it's always going to be the y value of your vertex. Okay, the next one is new. It's called the focus. And you're going to be doing or figuring out the focus a lot more in pre-cal next year. But your focus is on the axis of symmetry. So let's say I have a parabola that looks like this. I have an axis of symmetry going right down through the middle. Okay, my focus point is going to be inside the parabola, okay, but it's still going to be on the axis of symmetry. Usually it's pretty close to that vertex. It's sometimes so close that you can't even plot it. It's that close. But it's going to be somewhere in here. That's going to be your focus. It's going to be inside the parabola on the axis of symmetry. Okay. Now the way you find the focus, since it's on the axis of symmetry, it's going to have the x value of your vertex. So whenever we talked about yesterday the vertex being HK, I'm going to put H here just so you know it's the x value of your vertex. And you can write it out if you want. Now your y value, you're going to have to actually figure out. Your y value is going to be k plus 1 over 4a. And you'll see more of how to do it whenever we go through examples. But k, if you remember, is the y value of your vertex. And then a is the first number in your quadratic equation. It's that number with x squared in standard form that we talked about yesterday. Okay, so we'll go over that more here in a little bit with an example. But just know, like, this is what a focus is. That's how you find it. It's not too bad. The next one is a directrix. Same with this one. You're going to be using this more in pre-cal with ellipses and hyperbolas, stuff like that. But your directrix, if I have a parabola that looks like this, okay, your directrix is going to be below the parabola. It's a line. It's a horizontal line, okay, like this, which means since it's a horizontal line, it's going to be y equals something, okay? So you have to have y equals, and it's actually going to be y equals k minus 1 over 4a. And we'll go over it more with the examples. But your focus, the y value is k plus 1 over 4a, and your directrix is k minus 1 over 4a. All right, domain and range, you know how to do. Roots, you know how to do. So let's go ahead and go back to the front of your notes with the examples, and let's try some of these. Okay, so number 1, we have y equals x squared plus 4x plus 3. Okay, what I want you to do is go ahead and tell me what form this equation is in. This one is in standard form. The way you know is standard form is usually where it has 3 terms. You have an x squared, an x, and a number by itself. Okay, so this is standard. Okay, and with standard, the way we find our vertex, if you remember from yesterday, x equals negative b over 2a. Okay, so we're going to have the opposite of b, which for this problem would be negative 4 over 2 times, and my a is 1. Okay, so negative 4 over 2 times 1. So what would that be? Negative 4 over 2, which is negative 2. Okay, so I'm going to go ahead and put that. The x value of my vertex is going to be negative 2. Alright, which means my axis of symmetry will also be x equals negative 2. Okay, it's the x value of your vertex. The max or min value, I can tell without even graphing it what my if it's going to be a max or a min. Look at your equation. You're going to ask yourself, is this parabola flipped or is it right side up? So look at your x squared. It's positive. That means you're going to have a normal right side up parabola. So you're going to have a minimum value here. And it's going to be y equals something. We don't know what that is yet. We don't know what the y value of the vertex is. So, but you can tell if it's a max or a min. Focus is next. Remember, focus is on the axis of symmetry. So if our x value for our vertex and our axis of symmetry is negative 2, so is our focus. Okay, it's going to be negative 2. Directrix. Okay, we can't figure that one out yet until we know the y value of the vertex. So we can just put y equals for now. Okay, our domain. Okay, if you remember from before, domain for parabolas will always be all real numbers because it's always going to go to the left forever and ever and then to the right forever and ever, no matter if it's moved left, right, up, down, flipped, it doesn't matter. It will always be negative infinity to positive infinity, or you can put all real numbers. Okay. Range, we don't know the range until we figure out the y value of our vertex, our minimum value. In roots, we're going to have to see the graph on that one to figure out what our roots are. Okay, so let's go ahead and go to the calculator because we need to figure out exactly what our vertex is and some points around it to figure out the rest of this information. Okay, so y equals, our equation is x squared plus 4x plus 3. Okay, go to your table, so second graph. Like we did yesterday, you want to see some points around the vertex, and our vertex is at -2. So you can kind of see what this parabola is doing. Let's go ahead and plot these points on your notes. So let's see, we have the point -4, 3. If you keep going up, we have the point -5, 8. That'd be a good point to plot. Okay, so -5, 8. -4, 3. -2, -1. And then, I'm sorry, -2, -1. And then that parabola starts coming back up. So we have the point -5, 8. We have the point -4, 3. -3, 0. -2, -1. And then that parabola starts coming back up. Like that. Alright, so we can draw our axis of symmetry through the middle. Okay, we're going to make sure we have all of this information filled out now. So our vertex is -2, -1. Okay, we already found the axis of symmetry. We know it's a minimum value at y equals -1. It's just the y value of my vertex. Okay. The focus, if you remember, the focus is k plus 1/4a, right, on the y value. Okay, so we're going to take the y value of our vertex, which is -1, and we're going to add 1/4 times a. And for this problem, my a is a sneaky 1. Okay, that's the number in front of x squared. So -1 plus 1/4 times 1. Okay, and you can put it in your calculator. Make sure if you put the whole thing in, even the 4 times 1, you have it in parentheses. Okay, or else it will be wrong. You have to put that whole